In this video, we are going to discuss Chapter 3 Sequence and Series. Okay, so in the sequence and the series, we are going to discuss two of it is arithmetic and geometric. And then we will discuss some of the application of the arithmetic and geometric series. Okay, so let us look at what is sequence and what is series. Sequence is a set of a number written follow certain rule, or we can say it as a certain pattern. Okay, so let us look at the first example, 2468. So you can roughly recognize this one is an even number, 2, 4, 6, 8, 10, 12. So generally, that is they are following certain pattern, that is every successive terms plus 2. Okay, and then the second one we are looking at is 1 over 3, 1 over 5, 1 over 7. So basically, maybe you couldn't recognize what is this, but you can recognize 3, 5, 7 is an odd number. So the next one is a 9, and then the denominator is the 9, and then the next denominator is 11, and the numerator are the same as 1. Okay, so this one is a following certain pattern. Okay, then the third one is a very famous sequence. It's called Fibonacci sequence. Okay, so if you look at this sequence, maybe you are in doubt how you can generate this one. Actually, you look at, you just ignore the first two terms. You looking at the third term, 2. And these two actually are the sum, is the sum of the first two terms, 1 plus 1 equals to 2. And then the second and the third term, when you sum them, you're going to produce the fourth. And actually, the successive term is the sum of two previous terms. Okay? And over here, we're going to introduce something is called general term. General term, we normally using the denotation as a Tn, is the nth term of the sequence. Okay, so if you want to generate the nth term for an even number, then you should know, you want to know on which term. Okay, so but the thing is, we just give a general notation, so we will use it as a Tn equals to 2n, and n is a greater and equals to 1. This is the starting value of our n. Okay, if you use n greater and equals to 0, so you will start your sequence with 0 and so forth. Okay, if you actually n over here, sometimes for this general term, we hardly want to use 0 and we hardly want to use negative, because nth is a counting number. That is our natural number, that is we don't want an negative as our counting number, or even 0. Okay, so the next one will be, if you want to produce the numerator with the changing patterns, so in our knowledge, that is even number is 2n. So odd number either is the one you plus 1 or you reduce by -1. So this one will be our our odd number general formula. But over here, you should notice that is, if you use 2n plus 1, and then the n is starting from n greater and equals than 1. Okay, so maybe some of you may ask, that is, when to use n greater than equals to 1, when equals n greater than 1. Okay, so basically we are just looking at our first term. Okay, if you want to produce 3, then I use 1, substitute into 2n plus 1, I will get 3. Okay, so if you want to use, if the starting is as an 1 over 3, 1 over 5, if you use 2n plus 1 is slightly not suitable. We will prefer to use 1 over 2n minus 1, and our n is greater and equals to 1, so I will produce 1 at the beginning. Okay, so this one, which n value is more suitable, you need to substitute back into the general terms to check whether is it your first term fulfilling when your n is greater or equals to 1. Okay, and then for the C, our famous Fibonacci sequence, that is the current term are the, okay, this is our current term, Tn, is the two term the sum of the two terms before. Okay, Tn minus 1, Tn minus 2. Okay, maybe some of you will ask, what is Tn minus 1? What is Tn minus 2? Okay, so let us look at our general, the way of we are writing our counting number. 1, 2, 3 means that every successive terms we plus 1, 4, 5, and then we put 3 dot means is so 4, and until the end term. Okay, and it's just a general end term, and the term after n we always call is n plus 1. Okay, so means is we plus 1 to the end, and then after the n plus 1 we can be n plus 2. Why is n plus 2? Is n plus 1 is n plus 2. So if you look back, okay, the one term before, the difference between n and the one term before will be 1, so will be n minus 1, and one term before of the n minus 1 will be n minus 2, and n minus 3, and so on. Okay, so this is how you want to get the general term, one term after the end, one term before the end. Okay, and before the end is n minus 1, after is n plus 1, and so on. Okay, so and then you must provide the first two terms for this sequence, the general terms of this sequence, because if you didn't give these two general terms, you cannot calculate the third term. Okay, and next we will look at some example on how you can generate the terms from these general terms. Okay, and what is series? Okay, series actually is adding the terms in a sequence, and normally we use s. S is actually stand for sum of nth term. It means that you are summing from T1, the first term, the second term, the third term, until the nth term, or sometimes we use as a notation sigma. Okay, and then the sigma, we have the underneath, okay, is indicating what is our variable to change. Over here we use I. Okay, actually is I, so this one should be Ti. So we are using the Ti as our notation, I as a variable, until when? Until the terms of end. Okay, so now let's say you have you want to sum 2 plus 4 plus 6 plus 8, and we know that from our previous one general term is 2n. Okay, so means that actually I should write as a 2i. So we are starting from summing from the first term until the infinity. Okay, and the second one is we want going to sum. Okay, why is until infinity? Because you see that there is a 3 dots at the behind here, means that you are adding until the end of the series, that is infinity. And for the B, we are only adding 1 over 3, 1 over 5, 1 over 7 until 1 over 11 only. So over here I only have 5 terms. So from the first one until the number 5, and the 2i plus 1. And actually we have a name for the one sum until only 5 term. We call it as a finite series, or you can say it as finite sequence. It's a stop after a fixed number. So means that for the 1 over 3 plus 1 over 5 until 1 over 11 is a finite sequence. And for the infinite means that we have a continuous, that means we have a 3 dot at the back. Okay, now let us look at the example 1. It is given the nth term of a sequence is an minus 6 over n plus 3. Write down the first 4 terms. If you notice here, that is, first thing, we have one variable, the a, and the controller over here is not the a, but actually is the n. Okay, so n is the one is going to change according to the increasing of our integer. So normally we start our n with 1, as I said before. It's a counting number. We count from 1. So I substitute n equals to 1 into the an. So it will become a1. Then nothing else, that is whenever you see the alphabet of n, you replace with the 1. So over here we have a negative 6 over 1 plus 3 is a negative 6 over 4. And we know that if we simplify, it's negative 2 over 3. For the second term is I substitute n equals to 2. So whenever I see n, I replace with 2. So I have a negative 6 over 5. And actually you can leave your answer as a negative 6 over 5. No need to change to negative 1 over 5. It doesn't matter. Okay, so the third term replace n with 3. So whenever you see n, you replace with 3. So over here it is very obvious. Negative 6 over 6 is negative 1. So that's why we simplify. And the last one over here we require is the fourth term. So whenever you see the n as replaced with 4, so you have this one, so negative 6 over 7. And this one, because it's only need our 4 terms, you can use the curly bracket and then arrange. You just copy back following the sequence, and please don't arrange or whatever. You just need to follow the flow only. Okay, then the second one is, it is given the n term of a sequence is this one, okay? And over here, B is only just a name for it. And then the controller over here is our n. So also they required us for the first 4 terms. So you replace the first one. Over here, please be careful if you see that is negative 1, okay? Whenever negative 1 with the power of a odd number, you will get a negative. If an even number, you will get a positive. So if you notice here, the output of this one is positive, negative, positive, negative. So whenever later on you see any sequence, is alternating the sign. From positive change to negative, from negative change to positive, and so forth, means that it must be consist of one controller is called the negative 1 power of n. Okay, and please don't put the negative 1 outside the power of n. Must be inside of the power of n, because whenever it's an even, then your negative will be positive. Okay, and the third one. Okay, the third one is the one a bit look like our Fibonacci sequence. If you see that is, you must provide people the first term. Okay, if not, let's say this one. If you didn't provide anyone with the first term or the starting term, it will require, as usual, we say, let's say you say over here n greater than 2. So C2 equals to C2 minus 1 minus 5. Then I know it's a C1 minus 5. If you didn't provide me what is the C1, okay, over here they did provide us. But if you didn't provide us the C1, that means I cannot calculate further on. Okay, I will start over here because I don't have the value of the C1. So in this type of the sequence pattern, that is, you must give people the first term or the first 2 terms to generate the subsequent terms later. Okay, so this one nothing much, is only thing that is you need to be careful in the calculation, because C2 rely on the value of a C1, C3 rely on the value of a C2, and C4 rely on the value of the C3. Once you calculate wrongly at one term, the value of the later term all will be getting a wrong answer. Okay, so number 4 is our submission. Okay, so how to rate our submission? Over here, the controller over here is I. Okay, I start from 1 until number 3. Okay, so means is I have I equals to 1. After that, I equals to 2, I equals to 3. Then I stop, because it says that I start from 1 until number 3. And whenever when I equals to 1, whenever you see the I, you substitute. So it means that this one is for I equals to 1. This one is I equals to 2. This one is I equals to 3. And then you just substitute whenever you see I replaced by 1, this one replaced by 2, this one replaced by 3, and then you can use your calculator and calculate and sum them up. So that will be your answer. Okay, so how about this one? Our K is the controller over here. So this is my K, this is my K. So, and it said that K start from 1 until number 4. So I have a K equals to 1, K equals to 2, K equals to 3, K equals to 4. Whenever I have a K, I replace with 1. Okay, this is 1, over here is 1. When this is the K equals to 2, I replace with 2, and so on. Then I calculate them, then I sum them up. Okay, now look at example 5. This one is the example 3.2 took from your module. The nth term of a sequence is given by Tn equals to 2Pn plus Qn squared. Determine the value of P and Q if T3 equals to 12 and T4 equals to 24. Hence, evaluate T10. Okay, so this one, Tn equals to 2Pn plus Qn is provided. Okay, they provided us. So, and then yet they provide us T3 equals to 12 and T4 equals to 24. What we're going to do is just took 3 as our n equals to 3. This one is indicating n equals to 3. Replace whenever you see n. Here is 3, here is 3, and then you calculate inside. So it's a 6p plus 9q, and then equals to 12. This 12 is from where? Is the one is provided. Okay, this one is the by substituting n equals to 3. Okay, so the second one, the T4 actually is n equals to 4. So I'm going to substitute 4 into my previous of the Tn. So it's a 2p multiplied by 4, and then q multiplied by 4 square, and this one you 4 times 2 is 8p plus 16q equals to 24. 24 is the provided information. And then now I only took these two equations. 6p plus 9q equals to 12, 8p plus 16q equals to 24. These two form a simultaneous equation 2 by 2. So excuse me, so I key in excuse me, I key in into my calculator, and then my calculator will provide me answer p equals to -1, q equals to 2. So I substitute P and Q into the Tn. So this is my Tn after I already know my P and Q. And the question asks us evaluate T10. So I just know that my n now is going to replace by 10. So I replace 10 into this one. So I get 180. Okay, so then the next example is you've been provided a sequence. Oh, sorry, you've been provided a series, and then they ask you to change back into a summation notation. So now if you look at it, okay, sometimes unless the questions you know that is an arithmetic or geometric, if not, then you will just need to recognize, okay, you just go to analyze what is the pattern of the series. Okay, so this one, if you think as a 1/2, 2/3, 3/4, and then you will be having a little bit clueless how this pattern forming from. But the thing is, if you separated the fraction into the numerator and denominator, when you look at the numerator is 1, 2, 3, so you already can recognize the next one is a 4, and so on, and then the last one will be the 14. Okay, and so this one normally when you have a 1, 2, 3, so means that this is our normal counting number as an nth. Okay, and then the denominator 2, 3, 4. Okay, so you also can notice that is the term with after is +1 +1, but over here you are starting from 2, compare with the previous one starting from 1. So what is relationship 2 and 1? 2 actually is 1 plus 1. 3 is 2 plus 1. So you can change it into n plus 1. So it means that the denominator need to be add 1 compared to our numerator. Okay, so generally I have n over n plus 1. What is my starting point? My starting point is I start from number 1 because I start from 1 at the top here. And then when I end at the number 14, so I only have a 14 terms. So this is called our summation notation. Okay, and then the B is a little bit slightly not common to see. Okay, but the thing is, for a long period that time, you will be quite familiar with this kind of a number. Then maybe you say that what is this number? But if I say that you have 1, 8, 27, 64, 125, most probably you can recognize what is this pattern. Actually, this is 1 power of 3, 2 power of 3, 3 power of 3, 4 power of 3, and 5 power of 3. Okay, so now, but the thing is, compare with 1, 8, 27, 64, 125 with our original question, each term is less 1 from the one over here. So means that we're going to have a 1 cube minus 1, 2 cube minus 1, 3 cube minus 1, every 1 minus 1. So it's become n cube minus 1. And then our control word is n. Okay, maybe you can say that is, you don't like n. Can you use I? Can you use k? Can. You can use summation. I equals to 1 and I cube minus 1. And until where? Because you only have a 5 term, so your over here is 5. Okay. We hardly write I equals to 5. Normally we just drop it because we already know that is when the at the bottom when it say I equals to 1, so I already know that the control word over here is I. And the B at the bottom here, you must write I, J, K, and so on, because that is the things that you informing people what is the controller alphabet you are using. Okay, after that, we're going to look at the second part. It's called arithmetic and geometric. Okay, arithmetic and geometric have a very, very clear patterns compared to the one we have, okay, with our normal sequence. Okay, in arithmetic sequence, there is a common difference between successive terms. Okay, so means that term 1 and term 2, this is called successive terms. Okay, they must have a similar common difference. Okay, so from 2 to 6, I plus 4. 6 to 10, I plus 4. 10 to 14, I plus 4. They must have a common difference. Okay, why is called common difference? Because normally we use the second terms minus the first term. We use the 10 minus the 6. Okay, so that's why it's called difference. Okay, if any term is subtracted from the next term, the result is always the same, and this is called the common difference. Okay, so regardless, if you see that is, if you see a sequence, okay, with a increasing number 2, 6, 10, 14, 18, 22, okay, that means your common difference must be a positive number. Okay, if your common difference is a negative number, so you can notice your sequence is decreasing. Okay, there is one thing very special about our arithmetic, means that once you see the number is all positive and increasing, it is impossible you will get a negative term. Okay, and if this one, if you see positive, but it is decreasing, okay, it is decreasing, so that means that is at one time you will see a negative value. Then once you see that negative value, you will never back to a positive value anymore because your sequence is decreasing. Okay, because this one is not like our geometry. Geometry is a slightly different. You can be having the alternating sign also. It is possible. Okay, so and then for general term of our arithmetic, because we know that we always say we name our first term as an A. Okay, our first term we name it as an A, and our common difference. Okay, we use the alphabet D to represent common difference. So the first term we know that is T1 equals to A. The second term actually is the difference between the second and the first one actually is the common difference is A plus D. Okay, after that is A plus 2D and so on, and our general for the n term is A plus n minus 1D. Okay, so if you want to know T10, okay, so if you want to know T10, so it's A plus your n over here is a 10 minus 1 multiplied with our D, so that's why actually is A plus 9D. Okay, so this one is n term, the general. Okay, and then the common difference. Okay, because the D, the common difference is the same for every terms. That means that if regardless you use T3 minus T2, or you use T10 minus T9, or you use T20 minus T19, the D is always the same. So it doesn't matter which pair you want to use. Okay, and then we go for the arithmetic series. Is we have the sum of the terms in our arithmetic sequence. Okay, so over here you can see that we have two different formula. Sn equals to n over 2a plus n plus 1d, and Sn n over 2a plus L. Actually, L is our last term. Okay, when to use which one? General, we will use the first equation, but in certain of the questions, if they provided us the last term, it is more convenient that is we use the last term. But the thing is it anything wrong that you use which one? No. Okay, both of them are interchangeable. Okay, over here you need to notice one thing is Tn. Okay, if you want to know Tn, if they provide you Sn or they provide you Sn minus 1, so actually we can calculate our Tn by this formula, because let's say I have an S4, means is T1 plus T2 plus T3 plus T4. And if I have a S3, is a T1 plus T2 plus T3. If I subtract these two, I will get this one minus T1 minus T1 gone, T2 minus T2 gone, T3 minus T3 gone, and then I have a T4 where my S4 minus X3. So this is how we can find our T4 or our Tn by using the formula of Sn and Sn minus 1. And now we look at our geometric sequence. The difference between geometry and arithmetic is the arithmetic is common difference. Okay, so means it's the second term minus the first term and the 10th minus the 9. But in geometric sequence, they are common ratio. Okay, it's not common multiply, because we use the after terms divide the previous term. Okay, so that's why it's called ratio. Okay, and when you use dividing, this must follow a certain pattern. So for example, when I have 1, 3, 9, 27, I use 3 dividing 1, I use 9 dividing 3, I use 27 dividing 3, all must give me the same ratio, that is 3. And if you see, if the common ratio is a negative value, so if you notice that this is positive, negative. Okay, so then the common ratio, when it is a negative value, you can have a alternating sign. And For the common ratio, if you have a 2 over 3, okay, it is also possible. So if you notice that it will be slightly a little bit odd, okay, 3 to 4 over 3, 8 over 9. Maybe sometime you will see you will get a whole number and then back to fraction again, okay. So we no need to memorize the pattern. The only thing that is you need to remember, arithmetic is following a pattern that is either all the series or the sequence must be increasing or decreasing, and the pattern of it is difference, okay, means is a second term minus first term and so on. But for geometry, it's a ratio. And then for the general terms, because it is a ratio, then we use the alphabet R to represent the ratio, and our first term is still the same using A. So, and the first term is start from A, the second term is multiplied with R, and the next term is multiplied by A square. So general term is Tn ARn minus 1. Okay, and if you want to get the common ratio is T2 over T1 and so on. Okay, and then for the series, you also have 2, but this 2 is not like the previous one, the first and the last term, but this one is for the R less than 1 or R greater than 1. If your R is less than 1, okay, so you use 1 minus Rn. If your R is greater than 1, you use Rn minus 1. So, and unfortunately, this one you have to memorize. And please memorize it correctly, because this one is Rn minus 1 over R minus 1, and compared to our this one is AR power n minus 1. Don't put the negative 1 down. Okay, so let us look at the comparison between arithmetic and geometry. In arithmetic, we have A plus D, A plus 2D. In geometry is AR square. And for the arithmetic, the consecutive terms, we use common difference. And the geometry is common ratio. So it's Tn over Tn. This one is a minus. If you want to show, let's say a sequence is a arithmetic, so you just need to find the difference between two terms is a constant, then it is an arithmetic. If the ratio is a constant, so it is a geometric. The general term for the arithmetic is A plus n minus 1D, and for the geometry is AR power n minus 1. Okay, the n minus 1 is the power. Okay, and then both, if you can calculate your Tn by using Sn minus Sn minus 1. And for the series, okay, for the arithmetic, you have 2. Is the one I said before. Either you can use A plus the last term, or you use 2A and plus n minus 1 D. Or the geometry, we also have 2, but the only thing, this one is rely on what is the value of R. Either is greater than 1 or less than 1. As I mentioned, this one is A power of n minus 1. This one is Rn minus 1. Okay, the power is only n only. Okay, so let us look at the first example for arithmetic and versus our geometry. And the example 1 said, the first, second, and the nth term of an arithmetic. Okay, this question is very kind. Let's tell you that it is an arithmetic sequence. And the first is, this one is a T1, this one is the T2, and this one is an Tn respectively. Okay, so, and we already directly, when people told us this is the T1, directly I said this one is an A. Okay, so my A directly I know is 2. Okay, so first thing after that, what is the question requesting for? Find the value of n. So means that they want to know on which term they give you the value of 58. Okay, and for the value of that n, find the exact value of the sum of the n. So means that what is the requirement of the question? They ask you to look for the n, and then they look for the Sm. Okay, so from here, we can know that our A equals to 2. What is our T2? T2 actually is we just, because it said that it's arithmetic, so in my mind must be Tn equals to A plus N minus 1 D. So if you need T2, so my A I already calculated. I already know it's a 2 plus 2 minus 1 D. So it's 2 plus D equals to 4 because, is equals to 6. Okay, so this one, the 6 is provided by is provided as an information from the question, is a 6. So my D is 6 minus 2 equals to 4. Okay, and once we already have our A and our D, so when we want to know what is the nth term, means to give us the 58, so I will Tn equals to 58, and I use the A plus N minus 1D. So I substitute my A as 2, my D as 4, N is the one we are looking for, and then we have some algebraic manipulation, so my N equals to 15. Once I know my N equals to 15, so I can directly use this one as N. As 15 is the N over 2, 2A plus N minus 1D. I substitute all the value I have, and then I get 450. Or, if you don't want to use this formula because you say that is, I know the last term is 58. So you can use the formula as A plus L. And then what is the N? N is the 15. So regardless what, you need to find the N also for 50. Okay. And the example 2, the second term of an arithmetic. Okay, so this is arithmetic, and then the T2 is 7. The sum of the first 4 term, okay, so means is S4 equals to 12. Find the first term and the common difference of the sequence. So they are looking for A and D. So what we need to do is arithmetic. So I have what is the general term. So is A plus N, Tn equals to A and minus 1D. And Sn equals to N over 2, 2A plus N minus 1D. And you just substitute for the Tn, the first one, you substitute N equals to 2. For the second one, the N substitute as 4 into, then I form 2 different equations, and then I key it into the calculator to solve this simultaneous equation. So I get my A is 15, my D equals to negative 8. And then we look at the example 3. Consider the geometric sequence. Okay, this now finally we reach to a geometric sequence. Negative 3, 6, negative 12, 24. Write down the common ratio. So last time we already said once they are alternating, so means that I must be involving negative. So actually we doesn't care also, but we only know that this one is the first term. T1, T2, T3, T4. So this is the information. So they are looking for the common ratio and find the 15th term. So what we do is, we know that T1, as usual, T1 actually is our A, is negative 3. And we want to find our common ratio. So it doesn't matter. You use 6 over negative 3 or you use 24 over negative 12. They both will give you the same, is negative 2. Once I have my negative 3 and negative 2, I want to find my T15. I just substitute into the general term for a geometric sequence. Then I substitute into the value, and then I got it. Either you want to leave your answer as a negative 3 to power of 14, or you want to give negative 49152 also can, because the number is quite large. Okay, so but excuse me, it depends on you. Okay, now, so if you notice that is, for this part of the questions, it is very important that is, you must know whether the question being asked is a geometric sequence or is an arithmetic sequence. Once you already can recognize which one is, whether the question is a geometry or is an arithmetic, then you already know that which set of the formula you are going to use. Example 4. How many terms of the arithmetic sequence? Okay, if you see that, notice although it's a negative, but the value is become increasing. Negative 6 to negative 5, actually the value is increasing. So in your brain, you already know that the common difference must be a positive number. Okay, I needed to give a sum of negative 25. So from here, we know that the first term is negative 6. So I want to know our common difference because the question already told us it's an arithmetic sequence. So I just use the second term minus the first term. I get my common difference is half. So I want to, okay, because they want the sum of an negative 25, so I no need to think much. I just plug whatever I have into the equation of an Sn equals to n over 2, 2a plus n minus 1d equals to negative 25, and I calculate, I simplify, and then I know that is this one actually is a quadratic equation. I use the calculator, give me 20 or 5. And then you may ask, why there are two different answers? Okay, so then now you have to look at it. Okay, means that actually this sequence is very special. From a negative 6, you keep on increasing, and then you will reach later a 0. After that, you will become a positive value. Okay, because this one are negative, when you are plus with a positive, the value will be cancel to each other, so you will get 2 times of the same value. Okay, so then you leave your answer because the question didn't say the first or the least terms. Okay, there are certain questions saying that is how many what is the least term of the arithmetic sequence are needed. If they ask for the least term, you give 5. But since this question didn't say anything, you just give both answer. Okay, so let us look at example 5. The first 4 term of an arithmetic sequence. Okay, so they must tell you the first 4 is an arithmetic, and where your a and b are constant, find the value a and b. So from this information they given us, the first one is 2, and then we have no more idea, so we're looking for the d. So then what is d? D actually is t2 minus t1 equals to t3 minus t2. So I just use this one. And maybe you said that is, can I use t4 minus t3? Yes. Actually, if you notice here, this is the third pair. This is the second pair. This is the first pair. Okay, so we need to have minimum 2 equations to get us the 2 different value of variable. Okay, because this one is equal, so this one, my t3 minus t2 equal to t2 minus t1. So I get the first equation is this one. Actually, this one is my first equation. And from here, fortunately, it's cancel off my a. So I already have my b equals to negative 3. And what I need to do, I get my t4 minus t3 to get for my value of my a. So I substitute back my b inside here. So I get the value of my a. Okay. Now, we look at example 6. Find the sum of arithmetic series. Okay, the sum of this one, the first one is 17, the last one is 417. Okay, so I can tell you this one is the first one, this one is the last one. Okay, then you already say bingo, I can use the formula of the n over 2a plus l. But unfortunately, what is your n? Okay, so what we need to do, we need to find for our n. So now we need to look for, we need to investigate what is our which number of our, which term is for our 417. So I know, then we use the general formula Tn equals to a plus 1 n minus 1d for the 417, and I know 17 is my first term. What is my d? 27 minus 17 actually is 10, and I already get my n equals to 41. So once I already got my n equals to 41, straight away you can substitute into this formula. If you don't like, actually you can still use the 2a plus n minus 1d. They are the same. Okay, so now what is example 7 asking for? Find the sum of the positive terms of the arithmetic sequence. Then you say that is why all are positive. But if you notice, 85 to 78, 71, so the sequence is decreasing. So there will be have a chance that this sequence is going to a negative. Okay, so now since they are only interested with our positive term, so on the other way that we are looking for, who is our last positive or our first negative? Okay, so and then because we do know what is our last positive, but it is easier for us to look for who is our last first negative. Okay, so I want to know my first negative who is less than 0. So now my A is already provided from here, 85. What is my D? D is just 78 minus 85 is minus 7. So I substitute into here, then I look for my N. Okay, over here is 93 over 7. So it's 13.28. Okay, and from the beginning of this video, I already said that N is a counting number. So it is impossible in a decimal point. So maybe you say that 13.28. 13.28, I should round down following the rounding system. But if you notice over here, this is not implemented in this type of questions. We should know that if you have the 13.28 term will give you the negative terms. If you use 13, okay, what is going to happen? If you use 13, it will going to still giving you a positive, because it said that this 13.8 is the starting of negative. So means that the one before here must be positive. After this, all must be negative. Okay, so we will looking for the next integer, which is going for our 13.28 is 14. So if you look at it, if I substitute 14, I will have a first negative value. Okay, so once I already have I know that T14 is my first positive, first negative. So means that my 13 is my last positive. Okay, so means it's the last one is my positive. So I just sum for the 13 terms. So then I get my answer. Okay. For example 8, the sum of the first 4 terms of a geometric sequence is 130 and its common ratio is 1.5. Find the first term, the 8th term, and the least value of n, which sum of the first n term of the sequence is greater than 30,000. Okay, now since over here they only give us the sum of first 4 term and the common ratio is 1.5, so means r is greater than 1. So I'm going to use Rn minus 1, R minus 1. So I substitute every one inside, and then I get my A as a 48. So then my A is 48. Once I get my A is 48, my R is 1.5. So easily I can find my T8. Okay, just substitute everything inside, and then I got this one. And the least value, so I use back, they want to greater than 30,000. So greater, I substitute everything. Okay, so if you look at this one, please recall back, this is what you learned in your chapter 2. This is called the inequality for your index. So since the base both are not the same, this one is base 1.5, this one is 313.5, so no point to change to the same base. So we take the log from for the left and right. So and then I calculate by using, and then it's approximately 14.18. Then you again, is it 14 or 15? Okay, so to make sure to actually, if you're not very sure, you can sum it as 15 x14, and then very clearly say x14 is not enough. Actually the f15 is the one greater than 30,000, and you must know that is the n never be a decimal point. Okay, and over here it already say n must be greater than 14.18. so you cannot choose 14. Must choose the next integer is 15. Okay, so now in example 9, the first three terms of a geometric sequence k minus 8, k plus 4, 3k plus 2 respectively, where k is a positive constant. Okay, so the k is a positive. Find the value of k. So now I want, the only way I know this one is a, so I have no more idea. So the only thing I can find actually is our r. I use t3 over t2, t2 over t1, so I ratio them, and then I cross multiply and I solve this quadratic, and then I got two answers. And this question is very smart. They already told you the k is a positive, so you must reject that k equals to negative. Find the sixth term of the sequence. So sorry, this one should be the 6 should be the 8th term, because my answer I using the T8. So we just substitute inside there, okay, the T8, then substitute everything inside. And then maybe you say how to find the A or how to find the R. So the A actually is, we just substitute 16 minus 8 is 8. And then for our R, we just substitute 16 into here. 16 plus 4 is 20. 16 minus 8 actually is 8. 20 over 8 actually is 2.5. So we substitute everything inside. We got our T8. And they show that the sum of the first 10 terms, so means it's S10, then you substitute everything inside, and they say it's round to the 1 decimal point, so this one is the answer. Okay, so now example 10 is a little bit slightly different from the before, which they didn't tell you is a arithmetic or is a geometric. They only said that is how many multiples of 4 lies between 10 and 250. Maybe at the first place, when you hear of multiple, straight away you will think of it is a geometric. Okay, now then you should ask yourself, what is multiple of 4? So for example, 1, 4, 6, is 8, 8, 12, 16 is a multiple of 4. Okay, 4, okay, sorry, the first one actually is, okay, 4 times 1 is 4, 4 times 2 is 8, 4 times 3 is 12, 4 times 4 is 16. This is for multiple of 4. Okay, so now if you say that if this is a geometric, so 8 divided by 4, 12 divided by 8 must be the same, but unfortunately 8 divided by 4 is 2, 12 divided by 8 actually is 3 over 2. So they are not fulfilling into a geometric, so then it must be an arithmetic by, we keep on plus 4. Okay, so this one is an arithmetic. So now once we already know this one is an arithmetic, okay, because we must know this one is an arithmetic. When it is an arithmetic, then you straight away your brain must come out a plus n minus 1t. Okay, that's all. Okay, and now this asks how many of multiple 4s lies between 10. Okay, so after 10, the first one you know actually is 12. Okay, 10 cannot be divided by 4, but 12 can be divided by 4. And how about the last one? Okay, 250, you can simply use calculator, divided by 4 is 62.5. Okay, so the 250 is the 62.5. And if you choose 63, so means that you already crossed your 250. So we're going to choose our 62. Okay, so then if you are not very sure, you can calculate 62 and 63, and then very clearly our 63 actually is 252, is already more than our limit 250. So that's mean the T62, okay, actually the T62 over here is the 248. Okay, over here we have two ways to calculate, okay, because they want to know from the 12 until 248 you have how many terms. Okay, this, please remember, this 62 actually is from the 4 until 248. There is a difference, okay? So there are two ways to look at this question to calculate from the 12 to 248. The first one is, I know my T3, sorry, my 12 actually is my T3. Okay, this one, my T3 is 12. So I use the from T3 to T62 actually have 60 terms. That is, this one is slightly difficult to understand. Actually, it's 62 minus 3, and don't forget plus 1 because T is counted. Okay, or you can use another way, another approach, that is, you use A as the first term, that is 12, and then your D is still the same, 4, and you calculate the 248 is the terms number 60. Okay, so this is two different ways to calculate. The 248 actually belongs to terms number 1 for this sequence. Okay, and the example 11, solve the equation for 1, 4, 7, 10 until x. They want to know what is the x, which give you the sum of 248. So you just find the D, and your A is 1, so you just substitute everything, and then you can find that is your n either is 14 or n is negative 41 over 3. You already know that is n must be a positive integer, so you rejected n equals to negative value. So then you already know that what is the value of the okay, sorry. This one, the T14 actually, the x actually is 40. Okay, then example 12, the fourth term of an arithmetic progression. Okay, sorry. In SPM, you use the term of progression, or in some book they use progression, but in our module we use sequence, so they are interchangeable. The fourth term of an arithmetic progression is equals to 3 times of the first term. Okay, so T4 equals to 3 T1, and the seventh terms exceed. Okay, exceed over here in Malay we call it is melebihi the twice of the second terms. Okay, so means is minus 2T3 equals to 1, and then you just use the general formula for the Tn equals to A plus n minus 1 T, and if you have a T4, so you substitute 4 inside, and then you have a 7, you have a 3, you substitute, then you can form the equation. Over here, the only trick over here actually is the second equation. Okay, you can either you want to use as a T7, okay, exceed. Okay, so means is melebihi the T3 by 1. Okay, by 1 means is extra 1, so means that your 2 times, okay, sorry, 2 times of your T3 plus 1 is equals to your 7. Okay, and then the 7 example 13, how many 2 digits number are divisible by 13? Okay, so means that 2 digits means is the first one is 10, the last one is 99. So in between 10 and 99, how many of this number are divisible by 13? So we know that is T1 is 13, the first one is 13, and we want to know that is what is our last term, and then from this calculation easily we can find that is our n is equals to 7. So then I have a T7, so then from T1 is 13 and T7 is 91, so it's a 7 terms. Okay, and now we go for the last part of this chapter, application of our arithmetic and geometric sequence. The first example, a lecture hall has 20 rows of seats with 20 seats in the first row, 28 second, 31 the third, and so on. So you need to imagine the first one is you have a hall in this one increasing. The first one, the whole everything is 20, and the first one is 25, the second is 28, the next is 31. So Okay, you in your mind must come up two only, arithmetic or geometric. So we always tested for arithmetic because it's easier to pass. Okay, so 31 minus 28 is 3. 28 minus 25 is 3. So means that it's an arithmetic. Okay, so this is how we conclude it's an arithmetic. Then once they want to know the total number, so I have the total is 20, I have my A is 25, and my D is 3, so I substitute everything, so I got my answer. Then example 2, there are 25 trees at equal distance. Okay, so what you need to do, first tree, second tree, third tree, fourth tree, okay, and then you have until the last one is 25. Okay, this is the 25, this is the first tree, and they say it's equal distance, so this distance is 5, this distance is 5, and this one and the before also 5. In a line with a val. Val is perigi, so and then you can draw the val either is on the left hand side or the right hand side. Okay, so I draw my val on my left hand side, and from the nearest tree. So when this one is a nearest tree, so this one is 10. Okay. A gardener waters all the trees separately starting from the well, and he returns to the well after watering each tree to get water for the next. Okay, maksudnya they start from the well and then they take the water. He takes the water and walk until the first tree and then pour the water on the first tree. Then he walk back. And then he takes the water from the well again. Then he walk past through the first tree, reach the second tree, and back again. Okay, so that means he will be walking, go to and fro for 25 times actually. Okay, so now how you can generate this thing? Okay, so for the first tree, is 20 meter distance. Why? From the well to the first tree is 10. You go back is another 10. So it's 20. For the second tree is, okay, because I calculate from the first one, I go 10 plus 5. Then I go back is another 10 plus 5. Okay, is 30. And then the third one is 2 times 10 times, because you pass through 2 3, so that means you have this one. And for the 25 tree, actually is a number 24 times you pass through the thing is this one, and this one you will form a arithmetic sequence. Okay, so this one you can you need to do it in a slow motion to look at the pattern. So because the 10 is unchanged, 1 2 3 4 is increasing, so this one is the way how you form the formula. Okay, so now we look at the example 3. Koi joined a company with a starting salary of 28,000. Okay, in Western country, normally they will tell you the salary is in the yearly terms. Okay, not like in Malaysia, we always say in our monthly term. They normally state their salary in the year terms. Okay, he received a 2.5% salary increase after each full year in the job. Write a formula for the SN, the total amount in dollar that Koi earns in an year. Okay, so means that is, okay, so you want the first one. Okay, so the first year is 28,000. Then we have the second year. So second year is 28,000 plus with the 2.5% of the 28,000. So you're going to have the 28,000. I factor out 1 plus 0.25. Okay, and then I have 1.0025 of the 28,000. Okay, and if what is your T3? T3 is the this year, the money of your second year, 1.0025, 28,000 plus with the 0.00 10 only, 25%, 0.25 of the 1.0025, 28,000. Okay, so then you redo again, you will get a 1.0025 square of the 28,000. From here, we can see that this one is our A, and our R actually is 1.025. Okay, so I have extra 10. Okay, so then after that, so as a general, R is greater than 1, so I have this one. Actually, this answer is wrong, SM 28,000. Okay, Rn is R is this one 1.025, power of n minus 1 over 1.025 minus 1. Okay, so this is our Sn. Okay, then we look at our example 3.12. The price of a bungalow increased by 500 every month. Okay, if the current price of the bungalow is 180,000 and find the price after 2 years. Okay, now these questions, the things you need to pay attention is the after 2 years. Okay, so now let's say we have our current year month is 1800. After 1 month, okay, so I have T2 is 180,500, and then another 1 month is our T3, so it's after another 1 month. Actually, this is the another 1 month. The total is only after 2 months is 1,881. So if you see, they say after 2 years means it's after 24 months. So means is we are going to have T25, not looking for T24. Okay, this is called after. Okay, so and our D is our A is 180,000, our D is 500, and look for the T25. Okay, and then example 3.13, Sarah buys a LED TV by paying 12-month installment. Her first installment is 100, second installment is 120, third installment is 140, and so forth with an increment of 20 each month. Find the 7th installment. So very simple. A is 100 and then D is 20. Then you look for the T7. The price of the LED TV, so you're going to pay for the 12 months, so it's S12, so you got the calculation there. Example 3.14, John saved 50 in January, 100 in February, 200 in March, and so forth by doubling his saving every month for 1.5 years. 1.5 years actually is 1.5 years, or is already 18 months. Why it will be in months is more accurate, because is the question is giving you January, February, so it's in a month term. How much he saved in the month of October? So October is month 10. Okay, so it's a T10. So after that is after 1.5 years, so it's 18 months. So you substitute, you got the answer. And then over here, the price of a tin of milk powder increased by 3% at the end of each year. If the current price is 38 RM, calculate the price of the milk powder after 5 years. So means that it's a T6. Okay, it's a after thing. Okay, how long for the price of a tin of milk powder to exceed 50? Okay, so means that the price must be greater than 50, and notice over here, and cannot be a decimal point, must be an integer. Okay, and then this is the end of our video for chapter 3. Bye.